Bin packing. All right. So one-dimensional bin packing is called the stock cutting problem. And we've seen that when you're trying to cut 2x4s. And that's going to be the main kind of event. That's going to be what we talk about here with one-dimensional. That's what we're doing. If we did two-dimensional, imagine if you were making some sort of collage and you had all these pictures and you had to cover some two-dimensional space. All right. So you're putting these pictures and you're trying to fill up some space, and maybe you can't possibly fill up. Maybe you've got some wasted space over here, but you're trying to fill up 2 dimensions with pictures. That would be two-dimensional bin packing. 3-dimensional bin packing would be like these people pack in boxes. You're going to try and fit these cans into these boxes and fill as much space as possible and leave as little wasted space as possible. Okay, so we're still talking about optimization. We're trying to maximize, how much we use. We're trying to minimize our waste, minimize our costs. We have 4 different stock cutting algorithms, all right? And you're going to get confused because they all kind of seem like they're doing the same thing. But in essence, here's what they do. The next fit algorithm says put the next weight or board. We're talking about boards, we're talking about weights, we're talking about whatever we're trying to pack. It doesn't have to be boards. Put the next weight in the current bin. Next fit, current bin. First fit, put the next weight in the first bin in which it fits. Best fit, put the next weight in the bin with the least space. Worst fit, put the next weight in the bin with the most space. So I think it's kind of difficult because those words don't really describe, next fit, first fit, best fit, worst fit. Sounds like a Dr. Seuss book. Those words don't really seem to fit with what I just wrote down in red. So it gets kind of confusing. So I would keep this list out in front of you if you're trying to do one of these problems. What is next fit? What is first fit? That kind of thing. Okay? But it's kind of important to notice if the next weight won't fit or next board, open a new bin. So we're going to do some of these problems and you're going to be thinking, well, that's stupid. Why are we wasting the rest of that board when we could use it for this? Don't worry about that for now. There's going to be some waste that you don't feel good about, okay? That's okay for now. We'll deal with that later. So, first example. They're calling them 8-pound bins, but if you want to think of it as an 8-foot board instead, maybe that makes more sense to you to think of it as a board. We're trying to cut a board. Now, I need a list, and so I'm going to put 1, 2, 3, 4 6-footers, 1, 2, 3 5-footers, 1, 2, 3, 4 4-footers, 1, 2, 3, 4 3-footers, 1, 2 2-footers, and 1, 2, 3, 4 1-footers. Okay. I like to list the boards out in decreasing order. If they're just a jumbled list, it's going to help, I think, to put them in decreasing order pretty much on every problem. Okay. So again, if you're new to this, what I mean by this is this. Don't write this down. Picture this as like an 8-foot long 2x4, and I've got this 6 represents a 6-foot, a 6-foot cut out of that 2x4. So we might cut right here and say this is a 6-foot 2x4. Okay, and you can see there's 2 feet left over right here. All right, that's kind of, I said don't write that down. All right, but that's kind of what I'm looking at. All right, so we want to do the method of, what was the first one here? Next fit, okay? Let's do the next fit method, and next fit decreasing. Next fit decreasing, that just means we wrote all those numbers in decreasing order. If it wasn't in decreasing order, it might be a little bit more inefficient. Okay, so number of bins needed, I don't know yet. Waste, I don't know yet. We'll have to figure it out. So here's what we're going to do. The next fit said put the next weight in the current bin. Now remember, if the next weight won't fit, open a new bin. Okay? That's going to seem a little bit crazy at some point, but let's just see. All right, so the first cut is a 6-footer. The 6-footer, so I'm going to cut 6 feet. Okay, so you can draw that in. I'm going to put a little 6 right there, okay? There's a 6-foot cut. Now notice we've got 2 feet left, all right? But the next fit says put the next weight in the current bin. So the next weight, 6 feet, won't fit in there, so we have to open a new bin. So we make our new 6-foot cut right there. 6 feet, okay? Third one won't fit in the current bin, so we open a new bin. Same thing for the fourth one right here. Okay. 5-footer won't fit, so we move and we're going to do a 5-footer right here. Another 5-footer. Another 5-footer. There, we got 3 5-footers. Okay. 4-footer won't fit, so we've got to buy a new board. So here's a 4-footer right here. And okay, now here's where it finally gets interesting. Okay, remember what next fit says. Next fit, put the next weight in the current bin. Well, we've got room for that next 4-footer, so we put it right here, right? And then the next 4-footer, we don't have room, so we open up a new bin right here. And then that last 4-footer will fit right here. Okay, now, here's where you're not going to like it. Okay, next fit says put the next weight in the current bin. If the next weight won't fit, open a new bin. We're not allowed to go back and use this right here. Okay, that's what you would expect, and that makes a lot of sense, but that's not what this algorithm says. An algorithm is a set of steps that's trying to tell a computer what to do, okay? So you can't really, we don't have artificial intelligence for this. We're just telling it what to do, and the program says you've got to open up a new bin. So that 3-footer goes right here. Okay, now we've got room for the next 3-footer, so we put another 3-footer right here. Current bin, 3-footer doesn't fit, so we open up a new bin for that third 3-footer. The last 3-footer can go in that same bin right there. Now we've got a 2-footer. Okay, a 2-footer is going to work. 2-footer fits in the current bin. And then that next 2-footer, we've got to open a new one. Okay, it seems highly inefficient to do it this way because we've got all that wasted space over there to the left. It seems like we should be using that. Okay, but that's not what next fit says. Next fit says put it in the current bin. So we got a 1, and we can do another 1, and we can do another 1, and we can do another 1. Okay, so number of bins needed, it looks like we used 12 bins, or it looks like we would have had to buy 12 boards. Okay, now the waste, if you look at it, we've got 2 feet, 2 feet, 2 feet, 2 feet of waste, and 3 feet, 3 feet, 3 feet of waste, and 2 feet, 2 feet of waste. So if you add those numbers up, 2, 4, 6, 8, 10, 12, and 9 makes 21 feet. Okay, there's 21 feet of waste. Okay, but let's think about this as a percentage. Okay, There were 12 boards that were 8 feet. We bought 12 8-foot boards, so that means 96 total feet. Okay, that's how many board feet that we would purchase. Okay, and there was 21 feet of waste. So if you think about 21 over 96, 21 over 96, calculator, is 21.875%. That's not very good. That's very wasteful. That's very inefficient. And you probably were guessing that. You're like, well, why in the world didn't we use any of this stuff over here for some of those cuts? It seems very wasteful. So I don't know that algorithm is the most efficient one. We'll try another algorithm. Maybe we'll get a better answer. But for this one, looks like we needed 12 bins or 12 boards.